Area of circles, circumference of circles, they all use pi in them. Area is, again, the flat surface inside of the circle, the space that it takes, where circumference is like the perimeter of a circle. It's the distance around. And so when we're working with our formulas, we are going to stick with more area today. Circumference will shine itself a little bit later, but we're going to stick with area today, and the area formula is pi r squared. I prefer your answer to contain pi. As a pre-calc teacher, we do a lot that uses pi in the number. It stays as part of the number. So even though on our calculators we can find a pi key, don't use it unless you really have to, unless you need to figure out, well, what exactly is that I need to approximate the region that I'm looking at. But for us, pi will just remain in our answer. So when I'm doing a problem like A, find the area is pi times 17 squared. So the only thing that I have to calculate is 17 squared. And when I write it, I would write it as the number first, pi at the end, and still units squared. So my answer is going to contain pi. Pi will be part of it. Yeah. One thing that I do need to remember, however, is that the radius, if I have a circle, the radius goes halfway across the circle. It goes from the center to a point on the circle. Whereas the diameter will go all the way across. So if they give me the diameter, I can find the radius by cutting the diameter in half. That simple. The diameter is twice the size of the radius. So for this particular problem, if the diameter is 32, what's the radius? 16, because it'd be half of 32. And then we can plug it in our area formula. Pi times 16 squared. Only thing I need to figure out is what 16 squared is. This becomes 256 pi units squared. Not so bad, right? Pretty easy? Okay. We will on occasion be asked to work the other way. Still, if pi is in the answer, it's not very difficult to do. We can work with pi very nicely. So when we move down to the second set or second example, we've done a couple of these when we were looking at rhombi and trapezoids. You remember doing those where we were given the area and we had to find the missing variable? Well, I just have to again remember that the formula for area is pi r squared. And so pi r squared, I should write it as the area I know, 98 pi equals pi r squared. If there's a pi on both sides, I can just cancel it out. The pi goes, the pi goes. That means that 98 must be the radius squared. How do I find the radius? Square root. So I'll do the square root of 98 to find the radius. I'll go and do my repeated division on the bottom. Can I divide 98 by 2? Yes. What does it equal? 49. Can I divide 49 by 2? No. By 3? No. By 5? By 7? Yeah. So by 7. So for every 2, remember, I take 1 out. This is 7 times the square root of 2 is my radius. And I'll keep it in that exact form. Getting comfortable keeping things in the exact form, again, is going to be very helpful when you move on in your future math classes. So try your hardest to keep it as exact as you can. So let's go through the same concept here. The area is 153, and area equals pi r squared. So 153 pi is equal to pi r squared. What happens to the pi's? Gone and gone. That's simple. 153 is the radius squared. Square root. Oops, not squared anymore. Can I break 153 down? Can I divide it by 2? No. Can I divide it by 3? Can I divide 51 by 3? 17, I believe. So this is 3 times the square root of 17 is the radius. I don't want the radius. I want the diameter. The radius is half the diameter. Therefore, how do I find the diameter? Double it. Yep. So I'll take 3 times the square root of 17 doubled, so times 2. Oh, I don't know why I wrote that like that. That's ugly the way that was hideous. Ignore that. Ignore that. It would be 2 times 3 times the square root of 17, which we would write as 6 times the square root of 17. These are units, so I'll put units on. It's not units squared because it's not area, so working backwards. Okay, the last part, these are the last 2 things that we're going to do in our examples, and that's going to be work with problems where we have pieces. Lydia, stop throwing things across the room. We need to find the area of the shaded region, and our shaded region is going to involve circles and other shapes. So when I think about finding the area here, what I want to do is figure out the area of the exterior and remove the piece on the inside. Excuse me. Thank you. Okay. So on the exterior, it looks like I have a square. And it didn't show up, but it turns out that all of those pieces are the same. So here, just make those marks in there. This is an equilateral triangle embedded in that square. I need to know that so that I can figure out the area of that equilateral triangle using some of the things that we did yesterday. So let's start with the area of the square. That's the big outer part. So the area of the square is 16 squared. From that, I have to subtract the area of the triangle. So the area of the square is 16 squared. The area of the triangle is what I have to remove. Again, this goes to yesterday's stuff. If this side of the square is 16, what's the bottom side of the square? 16, okay? If I draw my altitude up, which I need for my triangle, what did I create? 30, 60, 90 triangles, 2 of them. So this is 30. I can pull that triangle out. What's half of 16? 8. That's the short leg. So what's the altitude? 8 times the square root of 3. Nice job. So the area of the triangle is 1/2 times the base times the height, or 64 times the square root of 3. So I would write this as 16 squared minus 64 times the square root of 3. I can figure out what 16 squared is. 256. So I would write this as 256 minus 64 times the square root of 3. I leave things exact. They're ugly, but I leave them exact. If you punch it in your calculator, you'll get a decimal. But this is how I would write this. This is 256 minus 64 times the square root of 3 units squared. Can you read that in there? Very ugly, but 256 minus 64 times the square root of 3 units squared. I'd leave it exactly like that, call it a day. Okay? Like I've been keeping the square root of 3 in these problems, and the square root of 2, and we even saw one with the square root of 105. I keep those in my answers. We're going to keep pi in our answers as well, or I'm going to. And so when I start to deal with an area of a circle when I'm finding that combination, I might have radicals and pi's all over the place. So let's go ahead and see if we can figure this guy out. I need to take the area of the circle and subtract from that the area of the square. So what's the area of the circle? 9 pi, yeah. We've got the radius. So it's pi times 3 squared, or 9 pi. So I'm going to take 9 pi and subtract. Now I have to figure out the area of the square. Oh boy, this might be rough. So, if this segment here is 3, what would this segment here be? 3, great. Making this diagonal 6. Agreed? Then I know that I have a square which has these marks, 2 sides congruent, so I'm going to pull that triangle out. What kind of triangle did we just create? 45, 45. How do we know that? If these 2 sides are congruent, these 2 angles have to be congruent. And if these 2 congruent angles have to equal 90, we can just divide 90 by 2, so that's a 45, 45. What do I know on this 45, 45 triangle? The hypotenuse. How do I get to the leg? By the square root of 2. Nice. So this would be 6 divided by the square root of 2. Now I know some of you have seen a pattern to this and they jump into it really quick. When I rationalize the denominator, I multiply by the square root of 2 on the top and on the bottom. I would get 6 times the square root of 2 over 2. That simplifies down to 3 times the square root of 2. So what's 3 times the square root of 2? That's each side of the square. What's the area for a square? 18, because you did 3 times the square root of 2 squared, right? Or times itself. 18. So I'm going to do the circle, 9 pi, minus the square, 18. So I write this as 9 pi minus 18 units squared. So a lot of sort of foreign looking pieces that are going to remain in our answers, and that is okay. It seems weird, but it is okay. Get comfortable with seeing things written like that. That's really it for the day.